Hello everyone. Today we're going to talk about transforming an equation of a parabola in vertex form to the equation of a parabola in standard form and then backwards from that. So we have talked so far about this thing called vertex form. Remember, vertex form is a equals 8x minus h squared plus k. That's called vertex form. Well, there's another form of the same parabola that we can use. It is called standard form. And it looks like this. Y equals a x squared plus b plus c. That's called standard form. So you're going to learn how to do two things today, and then you're going to practice more of that tomorrow. You're going to learn how to start with the vertex form and change that into standard form, and then after that you're going to learn how to take standard form and turn that back into vertex form. The equation won't change, meaning the graph doesn't change, just the way we're writing the equation changes. One is called standard form, one is called vertex form. Alright, so let's get to your notes page. Notes page should look something like this, should be the first problem. The directions say, use the information provided to write the standard form equation of each parabola. Okay, we see the parabola right now is in vertex form. So it's really a fairly easy conversion to get to standard form. The first thing you do is take care of this squaring. You've got to square x plus 1. And squaring simply means to multiply by itself. So what you're doing is this. You are doing x plus 1 times x plus 1. Then you have the minus 6 at the end. So x plus 1 squared becomes x plus 1 times x plus 1, and then we still have our minus 6 at the end. Alright, now we're going to do that thing that you've heard me call before foiling. I've got two binomials, so I can FOIL. That means first times first. X times x is x squared. Outer times outer. X times 1 is 1x. Inner times inner, 1x, and last times last. 1 times 1 is 1. And then I still have my minus 6. So combining like terms would give me x squared plus that and that give me 2x's, and then that and that give me minus 5. Look at that. I'm done. I have transformed from vertex form into standard form. That's all there is to it. You FOIL out your binomial, your x plus 1 squared, and then you add or subtract whatever's here at the end. Not too bad. If you need to stop, rewind, go back and watch again, please do so. But let's go on and look at some more examples. I've got 3 of these examples to go over with you. Alright, let's go here to example number 2. Well, you see a difference in example number 2. Yep, some of you knew it was coming. Maybe it wasn't quite as easy as I did that first example. But now we see we've got a negative 2 multiplied. So we have to multiply by negative 2 after we take care of this foiling. After we take care of this foiling, because exponents come before multiplication in our please excuse my dear aunt Sequoia. Don't make me spell Sequoia. I don't remember. Alright, here we go. So I've got my negative 2 out front. Then I've got this thing I'm going to FOIL. That thing is x plus 4 times x plus 4, all, after I FOIL that, I'm going to do plus 7. So let's do that. Start with this foiling. Negative 2 is still out front here. X times x, x squared. X times 4, 4x. 4 times x, 4x. 4 times 4, 16. And it looks just like that, plus 7 at the end. Alright, let's go ahead and combine like terms inside here. Not dealing with that 7 yet. We got to combine like terms inside. We have negative 2 times x squared plus that and that make 8x plus 16, all that plus 7. Before I can add that 7, we know that multiplying comes before adding and subtracting, so I've got to multiply through, distribute through this negative 2. Negative 2 times x is negative 2x. Negative 2 times 8x is negative 16x. Negative 2 times 16 is negative 32. All plus 7. If I'm moving too fast for you, feel free to pause the video, get caught up, writing everything down, and then move forward. Alright, my last step, I've got two numbers to combine down here. So negative 2x, I'm sorry, that's x squared. I forgot my squared here. Negative 2x squared. So negative 2x squared minus 16x, negative 32 and positive 7. Put those in your calculator and you'll get negative 25. So there we go. Y equals negative 2x squared minus 16x minus 25. That's about as hard of one as you'll ever get. I really don't see them getting any more difficult than that when we're going from vertex form to standard form. So that's what we just did. Remember, this is called vertex form. This is the same graph written in standard form. Again, if you need to pause, get caught up, please do so. All right, moving on to problem number 3. Here is problem number 3. We're going to go through the same steps again that we just did for problems number 1 and 2. We've got a FOIL. So this equals 3 times this whole thing, x minus 9 times x minus 9 plus 9 outside of there. So now we shall FOIL. My 3 is still out here. Inside here, x times x, x squared. X times negative 9, negative 9x. Negative 9 times x, negative 9x. And negative 9 times negative 9 is positive 81. All plus 9. Alright, now we're going to take care of our combining like terms inside here. So that's 3 times x squared. Combine those two, we get negative 18x plus 81, all plus 9. Alright, before I can add that 9, I've got to do my multiplication. Multiplying comes before addition. So multiplying that out, 3x squared, that times that. Now 3 times negative 18, check on your calculator for me, but it's negative 54x. And then 3 times 81, well, that's a little harder, but I think that's 243. 243 should be right. All plus 9. Final step is to add those two numbers together there at the end. Will give me y equals 3x squared minus 54x plus 243 plus 9 is 252. So there you have it. We've gone over 3 examples in about 10 minutes that cover moving from vertex form, which is this form, into standard form, which is that form. Hopefully that wasn't too tough for you. It does take some practice. You will have time to practice tomorrow when you have more of these problems. Now we're going to move on to the one which you may consider a little trickier and uses something that we have learned before. So now let's go down. Now we're going to move the opposite way. Problem number 4. All right, the directions say use the information provided to write the vertex form equation of each parabola. Then state the vertex. So now we're not starting out in vertex form, we're starting out in this form, which is standard form. And we have to move into vertex form. Well, doing this procedure is very much like completing the square that we learned how to do when we were solving quadratics. So let me go through here. I'll take it slow and show you what we need to do. I'm going to rewrite this first of all. And I'm going to give myself some space between the 12x and the 32. Y equals x squared plus 12x space plus 32. Now, since I'm trying to get this into vertex form, and we know vertex form is y equals a, x minus h squared plus k, I'm looking to make this part, this x minus h squared. Well, we know how we can get something that looks like that by getting a perfect square trinomial. So let me ask you to remember this. What would I have, let me change my colors here. What would I have to add here to make this a perfect square trinomial? Well, remember, we took half of this number and we squared it. Half of 12 is 6. 6 squared is 36. So I have to add 36. That will give me this part. But if I randomly added a 36, I'm going to go ahead and I'm going to take away 36 back here to even that out. So it's very similar to completing the square, but we're working all on one side of the equation. We didn't move anything to the other side. So now let's see what that gives us. This now gives us a perfect square trinomial that's x plus half of this number, x plus 6 squared, plus 32 minus 36 is negative 4. So it's actually minus 4. Look there, we are all done. We now have a parabola in vertex form. Now that it's in that form, I can ask you, what is the vertex? Well, you remember how to get a vertex. The vertex is the opposite of what's in here and what's out here. So the vertex of this parabola is negative 6, negative 4. All right, hopefully you don't think that's too complicated, but it's okay if you struggle a little bit. I'm going to go through 2 more examples here with you. At any time, you can stop the tape, you can rewind it, you can listen again, you can just catch up with your steps. Don't want you to be overwhelmed here. All right, going to the next problem, problem number 5. Here we go again. All right, I'm going to do the exact same procedure that I did last time. My first step, I'm going to write this over, leaving some space between these last 2 items. So that is x squared plus 2x. Leaving space, I know I'm going to be adding something here. Then I have my minus 2, and I'm going to be subtracting something here. If I add in a random number to an equation, I've got to take that right back out. So what number do I add here? Well, remember, half of this number squared. Half of 2 is 1. 1 squared is 1. So if I add 1 to this equation, I got to subtract 1 as well. So there we have it. This piece then makes a perfect square trinomial. So this will be x plus 1 squared. I get the 1 from right here, half of this number. X plus 1 squared, and then I have negative 2 minus 1 is negative 3. So there we go. It's now in vertex form. So now it's in vertex form. What is the vertex? Remember, the opposite of what's in here and what's out here. So the vertex is negative 1, negative 3. Just like that. All right, problem number 6. Let's scroll down here. There is problem number 6. Now, I'm going to ask you to stop the videotape and try this one completely on your own. You've seen 2. I think you can use those examples that we just did to do this third one. To do problem number 6. When you're done doing it on your own, turn the tape back on and see how you did. Please stop the tape now and do number 6. All right, hopefully at this point you've done number 6 and you're ready to review and to check that answer of yours. Let's do the same steps. Y equals x squared plus 18. We leave a space because we're adding something, plus 90, and now we have to subtract something. So, what do we add here? We add half of this number squared. Half of 18 is 9. 9 squared is 81. So if I randomly add an 81, I got to subtract an 81 also so that this balances out. This now is our perfect square trinomial, which gives me equals x plus 9. Oh, I forgot my x up here. Sorry, forgot that x. X plus 9, I take half of that number. X plus 9 squared equals 90, not equals, plus 90 minus 81 is 9. So there is my equation in vertex form. Hopefully a lot of you got that right. So what is my vertex now? My vertex is 9, 9. And that's it. Hopefully neither of those are too complicated. You're going to have a worksheet covering 1 through 3 and 4 through 6 tomorrow. Make sure you bring these notes back with you. If you need to watch the video again, feel free to watch the video again. Not a big deal. Thank you very much for paying attention.